So equation of a circle. And there's actually kind of two distinct ways of writing the equation of a circle, but the usual way, the kind of standard way, is x minus h squared plus y minus k squared equal to r squared. Where, oh, that's a good idea. I didn't think about that, Paula. I actually don't have a tablet. I know it's kind of a surprise, right? You feel like everyone, oh, I mean, I guess I kind of have a thing, but it's kind of small. Yeah, I could try that. I think I've gotten set in my ways, which is unfortunate because I should try to be more flexible, but I'll maybe explore that. It's not a bad suggestion at all. So if your circle is written like this, which is the standard way of writing the equation of a circle, then we can see, or it's true, that the center of the circle is the point h comma k, and the radius of the circle is r. The way I always kind of think of it is that the center of the circle is what makes one side of it equal to 0. So if you plug in h for x and k for y, you get h minus h, which is 0, and you get k minus k, which is 0. So this whole left side is 0. I will also point out the center of the circle is not a point on the circle, right? It doesn't satisfy the equation. It's still an important point to make note of, but it's not actually a part of the circle. And then the radius is just the square root of whatever's over here, if it's written in the standard way. There is also, and we'll talk about this too, a general way of writing a circle, which looks more like this. It's kind of weird. It's ax squared plus, it actually has to be a also times y squared plus bx plus cy plus d equal to 0. We'll look at this as well. Writing the equation of the circle this way is much less helpful because it doesn't show us what the center or the radius are right off the bat. So we definitely prefer the standard form to the general form. But we'll talk about how to deal with the general form. Okay. So let me erase this side. All right. So yeah. So we're going to graph the following circle. So we're going to graph the circle x minus 2 squared plus y minus 3 squared equal to 25. And depending on what kind of thing you're drawing your circle on, you can be very precise or not super precise. There was something I wanted to see. One sec. Oh yeah, cool. Yeah. So the center, so to graph the circle, you really need to identify the center and the radius. So the center here is going to be the point positive 2, positive 3. Right? If x is 2, this part's 0. If y is 3, this part's 0. So you get what you want. And the radius is going to be the square root of 25, which is just 5. So yes, when it's written this way, the center is just what makes this 0, what makes this 0, and the radius is the square root of that number over there. I'm trying to, sorry, get stuff out of my way here. There we go. Oh, except I want too many things on my screen. All right. So drawing this, there are many ways to draw a circle. My preferred way is the following. Plot the center. So I guess I should make some marks. So 1, 2. And then 1, 2. Okay, all this supposed to be 1 unit. So I go over to the point 2, 3, just right there. I'm going to draw the center even though it's not actually part of the circle. And then I'm going to plot 4 more points, 1 in each of the 4 directions. So I'm going to go 5 to the right. So 1, 2, 3, 4, 5. I'm going to go 5 up. 1, 2, 3, 4, 5. I'm going to go 5 to the left. 1, 2, 3, 4, 5. I'm going to go 5 down. 1, 2, 3, 4, 5. So there's the 4 corners of the circle. And then I'm going to try my best to draw the circle. Yeah, it's pretty good. It's not the best circle ever, but it's all right. You don't need to label the points, but you certainly can if you want to. So, right, so this point, which is the center, is 2, 3. And then each of these other points is 5 away. So this point to the right is 5 more in the x direction. So this point here is 7, 3. This point is 5 more in the y direction. So it's 2, 8. This point is 5 less in the x direction. So 2 minus 5 is negative 3, 3. And this point is 5 less in the y direction, which is going to be 3 minus 5, which is negative 2. I don't need you to label those points, but if it helps you feel like you've done a better job of graphing it, that's certainly fine. The one thing I will mention to make sure you're aware of is that when you're going the radius distance in any of the directions, like so when I went 5 down, I started at a height of 3, and I went 1, 2, 3, 4, 5. Make sure that you count the axis as like one of the things you're counting as you go down that many. I see there's a question mark, but I'm not sure what it's pertaining to. So if you want to clarify what that's about, you're certainly welcome to. Otherwise, I'm going to continue on. One other thing I'll say about graphing circles is we don't usually worry about finding any intercepts. We don't, like, obviously there are a couple x-intercepts and there are a couple y-intercepts. We don't worry about those. That's atypical, right? Most of the time when we're graphing a function, or actually this isn't the function, most of the time when we're graphing an equation, we often try and see where the x and y intercepts are. This is one exception to that. Okay. And then the other thing I want to point out is there's a couple formulas that are actually useful when finding things out about circles. So we have the distance formula. So the distance between the points x1, y1 and x2, y2 is given by, we usually use capital D. It's the square root of the difference in the x's squared, x2 minus x1 squared, plus the difference in the y's squared. It actually doesn't matter which order you subtract the x's and y's in. So you can do x2 minus x1 or x1 minus x2. Either way, you'll either be squaring a positive number or squaring the corresponding negative number. You'll get the same answer. Same deal here. So that's the distance. And the midpoint of those 2 points of x1, y1 and x2, y2 is given by, so when I think of the midpoint of 2 points, I really think about the average of those 2 points. So the midpoint of these 2 points is the average of those points. So you average the x coordinates. So the average of x1 and x2 is x1 plus x2 divided by 2. And the same thing for the y's. y1 plus y2 divided by 2. So those are 2 things that come up quite a bit. In fact, they're going to come up in this next question. Actually, not this next question. Sorry, a later question. But these are important. Really, the equation of the circle actually comes from the distance formula. You can kind of see how if you squared both sides of this, you'd have something that looked like x minus a thing squared plus y minus a thing squared equal to the distance squared, right? And you can think about how any point on the circle is the same distance from the center. So really, when you're finding the equation of the circle, you're just saying, oh yeah. In fact, let me just say right here. If you took the square root of both sides, you could say that the square root of x minus 2 squared plus y minus 3 squared equals 5. Well, that's exactly saying the distance between the point xy and 2, 3 has to be 5. And that's true for any xy that's on the circle. Tiny. Tiny. All right. I was going to go back and erase it. So, of course, feel free to pipe in with questions if you got them. Let's look at the next one. So typically we kind of want to be able to do both things. If you have the equation, we want to be able to find the center and radius. If you have the center and radius, you want to be able to write the equation. So what's the equation of the circle with a center of the point, the center point, 4, -3, and a radius of 8. So I'm just going to throw it into the formula, right? I know it's supposed to be x minus the x coordinate squared plus y minus the y coordinate squared equal to the radius squared. Now I would simplify this a tiny bit, not a lot. I don't want to multiply this out. That's not helpful. Leaving it like this is how we want to leave it in the standard form. But I do want to write this as y plus 3. So I'm writing this x minus 4 squared plus y plus 3 squared. And I probably want to square this too. 8 squared is 64. So that's how I would write the equation of this circle. I want to point out one kind of extra thing here that sometimes I don't. So let's do one more. In fact, why don't you guys try this one? So I want you to try writing the equation of the circle with center 0, -3, and radius 9. So go ahead and try that. I'll give you like a minute. All right, it's been about a minute. So I'm going to have x minus 0 squared plus y minus -3 squared equal to 9 squared. So that's going to be x squared plus y plus 3 squared equal to 81. And what I really kind of wanted to emphasize about this particular problem is that when you see an equation where you just have like x squared or you just have y squared, that coordinate, the x or y coordinate of the center is 0. So be aware of that, right? So if I gave you, if I said the equation of my circle was x minus 4 squared plus y squared equal to, I don't know, 7, then the center would be the coordinate x is 4, y is 0, and the radius would be the square root of 7. So just a couple things to be aware of. Erase. All right. And I'm going to keep just stubbing my toe. Do that. Oh well. I'm going to move this a little bit back here. That might work. So let's look at this next question. What is the equation of the circle that has, sorry, I'm looking at the wrong one, with a diameter whose endpoints are the following. Let's see here. -6, 1, and 2, 7. And who's, and sorry, I think that's all I want. Yeah, that's all we need. So I've got a circle. Can you please show us the other part of the board again? Yeah. Oh, one thing. Let me do one thing. You're welcome.
James, I have a quick question.
Go ahead.
So the center on that problem would be 0 and +3?
Which one? This one here?
Yeah, that one.
No, it's 0 and -3.
-3. Okay.
Right. So in fact, we were given the center and we found the equation.
Oh, okay.
Are you talking about this one, right?
Yeah, I was just looking at the bottom part.
So again, the way, if I have the equation, the way I think about how to find the center is the values of x and y that make each of these parts equal to 0. So x has to be 0 to make this part 0, and y has to be -3 so that -3 plus 3 is 0.
Okay. Thank you.
You're welcome, of course. All right. So now we have a circle and we don't know the center or the radius. We just know the endpoints of a diameter. So let's draw it, just kind of give us an idea of what this looks like. So I've got a point, -6, 1, and +2, 7. All right, it's not exact, but a diameter means that it goes through the center. So there's my center right there. And if we know the endpoints of the diameter, we can find the center as the midpoint of the endpoints. So the center is just going to be the midpoint, which is just the average of the points. So that's going to be the average of the x's, so -6 plus 2 divided by 2, and the average of the y's, 1 plus 7 divided by 2. Do you make sure that you add these? You're not subtracting them. And -6 plus 2 is -4. -4 divided by 2 is -2. And 1 plus 7 is 8, and 8 divided by 4 is, 8 divided by 2 is 4. So there's my center. And now we're going to find the radius. And you can find the radius in one of 3 ways. You can either find the distance between the 2 endpoints and divide it by 2. I don't recommend that because sometimes it's not a nice distance. It's like a square root of something, and then dividing it by 2 makes it kind of funky. I prefer to find the distance between the center and one of those endpoints. So let's find the distance between these 2 points. So the radius is going to equal the distance between that point and that point. So it's going to be the square root of the difference in the x's squared. So -2 minus -6 squared plus the difference in the y squared. So I did -2 minus -6. Now I'm going to do 4 minus 1. Okay, let's simplify this. That's going to see -2 plus 6 is 4. So I'm going to get 4 squared plus 4 minus 1 is 3 squared. Now be careful. I've definitely seen people accidentally say this is 7 because they said the square root of 4 squared plus 3 squared is just 4 plus 3, which it's not. So to do this, we have to square these and add them together and then take the square root. So that's going to be the square root of 16 plus 9, which is the square root of 25, which is 5. And then we have to write the equation. So we've got all the pieces. I've got my center. I've got my radius. Now I'm going to throw it into the formula and say, okay, the equation of my circle is x minus -2 squared plus y minus 4 squared equal to 5 squared. I think you could probably skip this step and just write the final answer, which is x plus 2 squared plus y minus 4 squared equals 25. Let's see. How do you know which? So it actually, so we can pick either one. And I will say, we could have done it the other way. meaning it really doesn't matter for the distance equation. You just want to keep the order the same. So in this equation, I did this is my x2, y2, and this was my x1, y1. But if I do it the other way, it'll still work out. So if I do the radius as the square root of this one minus that one, so -6 minus -2 squared plus 1 minus 4 squared, look what happens. I get the square root of -6 plus 2 is -4, and 1 minus 4 is -3. But -4 squared is still +16, and -3 squared is still +9. So it doesn't matter which way you subtract them, because if you subtract them one way, you'll get a positive number and you'll square it and you'll get something. If you subtract it the other way, you'll get the corresponding negative number, but if you square that negative number, you're still going to get the same value, right? So either way it'll work. Just make sure you're doing x's minus x's and y's minus y's. That's the place where often people make an error accidentally. All right. Okay, so a couple more. Just flying through this material. We might have time for questions at the end. Might have time to start section C. I guess that might be what I should do if we have time at the end. Is start C. But let's go ahead and look at the next question. So the next questions, I think the next two questions are involving circles that are written using the general form, which is where you don't have everything immediately visible. So let's look at this one, which is the equation of the circle is x squared plus y squared plus 2x minus 3y plus 11/4 equals 0. Okay, so we know nothing. We don't know the center. We don't know the radius. We know it's a circle, and the way we know it's a circle is, well, one, because I'm saying it's a circle, but really because you know you have a circle if you only have powers of x and y that are first powers and second powers, right? You have no other powers, and x squared and y squared have the same coefficient. So in this case, x squared and y squared both have a coefficient of +1. If they have different coefficients, you actually have an oval. But we're not going to deal with that. We're just dealing with circles. So here's the way we do this. There's two things I'm going to do in this first step. I'm going to bring any constant over to the other side, and I'm going to group the x's and the y's together. So I'm going to write this as x squared plus 2x. I'm actually going to leave myself a little space to add something else on. And then I'm going to also do the same thing for the y's. I'm going to do y squared minus 3y. And again, I'm going to leave myself a little space to add something on. I'm going to subtract the -11/4 from both sides. So I'm going to get a 0 here and a -11/4 over here. And I'm also going to recognize that if I add something here, I'm going to also add it here. And if I add something here, I'm also going to add it here. I'm going to give myself space. All right. So now what we're going to do is we're going to complete the square. And the reason we're going to complete the square is so that we can have an equation that looks like the standard form of the equation. And that's why we talked about completing the square last class as well, so that we can do the thing. So the way I complete the square is I take the coefficient of x or y, either way. I take this coefficient, I divide it by 2, and I square it. So 2 over 2 squared, that's going to give me a 1. And similarly, this one's going to be a little bit funkier. I'm going to take -3 over 2 and square. That pen does not look great. Pen might be trash. But -3 over 2 squared, I'm just going to square each part. -3 squared is 9, 2 squared is 4, so I get 9/4. Okay, and here's what's great about this. The reason we did this is because now these 3 terms factor and these 3 terms factor in a nice way, in a something squared kind of way. This here, you can either try to factor it right? And be like, what multiplies to 1 and adds up to 2? It's 1 and 1. So you're going to get x plus 1 times x plus 1, or x plus 1 squared. And similarly here, what multiplies to 9/4 and adds up to -3? It's -3 halves and -3 halves. Okay, -3 halves times -3 halves is 9/4, and -3 halves plus -3 halves is -3. Now, really, you don't have to think about it at all, because the number you're looking for is just the number that's in the parentheses here. -3 halves here, +1 here. Consistent with the colors here. And that's going to equal -11/4 plus 1 plus 9/4. So let's see, -11/4 plus 9/4 is -2/4. So this is going to be -2/4, which is -1/2. And -1/2 plus 1 is +1/2. I want to emphasize, because I've seen people do this as well. If you just add the -11/4 over here, I want it to be really clear that that is not the radius squared. Obviously, it can't, because it's a negative number. But I've seen a lot of people be like, "Oh, whatever you add there is just your radius squared." It's not. You have to do this completing the square part and add things to the side before you can figure out what the radius is. So here's what we've got. We've got the center is the point -1, +3 halves, and the radius is the square root of that number, which is the square root of 1/2. And I would probably, Yeah, I probably would. Usually we rationalize things. So if you have a square root of a fraction, you can say that's the square root of 1 divided by the square root of 2. The square root of 1 is just 1. But then I don't want to have an irrational number in the denominator. So I multiply the top and the bottom by the square root of 2. The square root of 2 times the square root of 2 is just 2. And the square root of 2 is just 1 times the square root of 2 is the square root of 2. So we might write that the radius is the square root of 2 over 2. Instead of writing it, this is the square root of 1/2. Either way is probably fine. Yeah, let me talk about that for a minute. I didn't ask you to graph this one, or we didn't say we're going to graph it. But let's go ahead and graph it just so I can show you something. But I should ask, are there any questions about this? Because I'm going to erase this before I graph it. All right, seeing no questions.
Sorry, I did.
Go ahead.
Yeah. So is it always necessary to rationalize denominators?
I would say generally no. It's not always necessary. It is often expected though. Not maybe by me, but so when someone says to simplify an answer, one of the usual things that is expected in simplification is to rationalize the denominator. So I'll try to let you know if I expect you to. And I would say in general, you probably want to err on the side of doing it if you're not sure whether or not you should do it. Especially when we get to trig stuff in the last third of the class, we have a lot of denominators that have irrational numbers in them, and we typically do rationalize them. But I wanted to graph this for you guys just because I want to show you how I deal with graphing things that have a radius that's not a nice integer or fractional number. The square root of 2 over 2 is something. So here's what I know. Well, I mean, I know some things, but what I want to say is that I know that the square root of 1/2 is definitely less than 1, right? It's actually bigger than 1/2. Right? So if you square root a number that is between 0 and 1, it actually gets bigger. Right? What's the square root of 1/4? Oh, it's 1 over 2. And 1 over 2 is definitely bigger than 1 over 4. So yeah, square roots of small numbers between 0 and 1 actually get larger, not smaller. So I know that the square root of 1/2, is between 0 sorry, not well, it is between 0, but I don't want something. It's between 1/2. It's a little bigger than 1/2. It's definitely smaller than 1. Okay, so now I'm going to graph it. So my center is -1, 3/2. So there's my, there's -1, there's 1, there's 2. And we also mark the halves with, yeah, sure. Okay, so I know it's a little bit bigger than 1/2. So I'm going to go a little bit more than a half away. So there's a half away. I'm going to go a little bit more, half away, a little bit more, half away, a little bit more, half away, a little more. So basically, when I'm graphing a circle and I don't know exactly the value, I could use a calculator, right? We could totally use a calculator and find out that the square root of 1/2 is, I don't know, about 0.7. But really, I just care kind of what numbers it's between. So if I know, like, for a different example, if my radius was like the square root of 17, I would be like, oh, that's a little bit bigger than the square root of 16, which is 4. So I would just go 4 and a little bit more. That's the way I would usually graph this. So what I'm really trying to say is don't worry about being super precise if your radius is a number that's not an integer number. Yeah, that's all I'm really trying to say with quite a few words. Okay, one more circle, and then we will do a couple word problem type things. Okay. So one more circle. I do want to graph this circle. I want to graph. I'm gonna change it just slightly so that the number is not super nice. Meaning so I got 2x squared plus 2y squared minus 10x minus 2y minus, let's make it minus, sorry. Yeah, sure. Minus, I want it to be bigger, let's make it -7. Sure. It isn't -5 in the notes. You can look at the notes if you want to see that one too. This one's gonna be slightly different. So there's an extra thing we have to do here. But first I want to bring this over to that side and group the x's and y's together. So I'm going to have 2x squared minus 10x plus 2y squared minus 2y equal to +7. But here's the thing. To really be able to complete the square in a convenient way, I don't want to have these 2's as coefficients. Question, Nicole.
If this is supposed to be a part of the guided notes, on our notes it says -5.
Yeah, I know. I'm changing the problem just slightly to make it a little bit more interesting. But yeah, so in the guided notes, the radius ends up being 3. In this example, the radius is going to be a little bit bigger than 3, just so that I can show you how the graphing thing I was talking about previously.
Oh, okay, thank you.
Yeah, but you're totally correct. The guided notes do say -5. So in this problem, before we can start completing the square, we really want x squared and y squared to have a coefficient that's 1. So we're always going to make the step of dividing both sides by whatever the coefficient of x squared and y squared is if it isn't 1. So I'm going to divide everything by 2. If I divide everything by 2, I'm going to get x squared minus 5x plus y squared minus y equal to 7/2. And I left myself room to complete the squares. So these ones are going to be a little less nice because they're both odd numbers. I'm going to take my -5 divided by 2 and square it. And that's going to give me 25/4. Similarly here, my coefficient's -1. I'm going to take my -1, divide it by 2, and square it. And that's going to give me a +1/4. It should always be a positive number that you're adding on because you're squaring whatever it is. So I'm going to get 25/4 and 1/4. Okay. Did I pick a number that wasn't super nice? That should be fine. Okay. So then this is going to factor. It's going to factor as x minus 5 halves squared. Because negative 5 halves times negative 5 halves is 25 fourths. And negative 5 halves plus negative 5 halves is negative 5. In a similar way, this part's going to factor as y minus 1 half squared. So it's always just the number that is half of this coefficient. That's what ends up going right there. And then it's going to equal 25 fourths plus 1 fourth is 26 fourths, which reduces to 13 halves. And then 13 halves plus 7 halves is 20 halves, which reduces to 10. So great, we have all the information. We have a center that is 5 halves, comma 1 half, and we have a radius that's the square root of 10, which is bigger than 3. So when I graph this, I'm going to make my radius 3 and a little bit more. If you prefer, you really can plug it into a calculator and find out that the square root of 10 is like 3.16 or something. It's not exactly that, but it's approximately that. But I don't think you need to do that if you don't want to. So let me go erase to this side. But I'm going to flip it so I can graph it. No, if I'm smart, I'll just, I will draw my, I can be smart. I can do things ahead of time on this side of the board. What's my center? That's fine. So let's go ahead and go to the other side. My center is 5 halves, 1 half. Didn't give myself enough room. So the center, 5 halves, comma 1 half. The radius, square root of 10. So 5 halves is 2.5. Halfway between 2 and 3, and 1 half is obviously 1 half. So this is 1, 2, 3. This is 1. My center is right about there. So I know I'm going to have to go 3 and a little bit more in each direction. Okay, so I'm between 2 and 3. I'm at 2.5. So I'm going to go 1, 2, 3, and a tiny bit more. I'm at positive 1 half, so I'm going to go 1, 2, 3, and a tiny bit more above the center. I'm going to the left, 1, 2, 3, and a tiny bit more. I'm going to go down, so 1, 2, 3, and a tiny bit more. On the other side near the R, is there a 53? The other side. No, sorry, that's a greater than 3. Yeah, fair question. My greater than did kind of look like a 5 there. So that's how I would graph this. All right. So that's really all there is to say about circles. They're pretty straightforward. Let's look at the 2 word problems. So, first word problem. It costs a sushi restaurant. So it costs $600 to provide a buffet. You couldn't imagine eating at a buffet yet. Sure. So if they charge each customer $15, write an equation for the profit in terms of the number of customers. So I'm going to go back to this side because we're got a limited amount of time. So if they charge $15 per customer, write an equation for the profit where X is representing the number of customers. All right, so how much money are we making? Well, not a lot if we don't have enough customers, right? So our costs are $600. So the profit as a function of X is going to be negative $600. All right, we're already $600 in the hole before anyone shows up. But then for each person that comes, we get $15. So we're going to get plus 15 times X. And actually, let me look at one thing here. Yeah, that's right. Yeah, I mean, I know that's right, really. So that's kind of it. And we can see that, right, if X equals 0, if 0 people come, we've got negative $600 plus 0. And if 1 person comes, we've got negative $600 plus 15, which is negative 585. And so on, right? You can keep doing this, right? If 10 people come, we're going to get negative 600 plus 15 times 10, which is negative 600 plus 150, which is negative 450. Great. The second question is, what's the break-even point? Break-even number of customers. How many people have to come so that we make back all the money we spent providing the fish? Well, that means if we want to break even, we want our profit to be $0. So we're going to set the profit equal to 0, meaning we're going to set negative 600 plus 15x equal to 0. So we're going to solve for x. I'm going to add 600 over here. So 15x equals 600. And then I'm going to divide by 15. So x equals 600 divided by 15. 600 divided by 15 is 40. Right? What I'm really thinking of is I know that 60 minutes divided by 15 is 4, because there's 4 15-minute intervals in an hour. And so 600 divided by 15 is 40. So 40 customers, that is the number we need to make back the $600 we spent. And then any additional customers would put us into the profit section, meaning we would be making money, which is why you would be doing it, I guess. Oh yeah, maybe you really like providing sushi. All right. Just got one more word problem. So let's take a look at it. So I'm going to start saying the words and I'll leave this up for a moment. So we're going to have a ball thrown upward with an initial velocity of 80 feet per second. And we're going to give the height equation as well. I wish I could write on the other side of the board while it was over here, but I can't because it would be upside down, which is too bad. I will say also, I will post the video, so if anything went a little too fast, you can always go back and look at it, or you can look at the notes on Canvas. So a ball is thrown upward with a velocity of 80 feet per second, which is pretty damn fast. I'm certainly not throwing it that fast. So the height of the ball is given by the equation h of t, the height of time t, is equal to negative 16t squared plus 80t plus 4. And the question we want to answer is, when will the ball be 100 feet above the ground? And what I really actually mean by this question is not just at what moment, but what interval of time. So for how long, right? Because the ball is going to go up. At some point, it's going to be above 100 feet. It's going to stay above 100 feet for a little while, but then it's going to come back down. So I want to know, when is the ball above 100 feet high? So we're going to set the height equal to 100. I know we're getting close to being out of time here, so we'll wrap this up pretty quickly. So I'm going to set this equal to 100. I do need to use the, I guess I can do it down here. So I'm going to set negative 16t squared plus 80t plus 4 equal to 100. I'm going to subtract 100. So negative 16t squared plus 80t minus 96 equals 0. I'm going to notice that 16, 80, and 96 are all multiples of 16. So I'm going to factor out a negative 16, or really divide by negative 16, actually is probably nicer. So dividing both sides by negative 16, I get t squared. 80 divided by negative 16 is negative 5. And negative 96 divided by negative 16 is positive 6. This factors t minus 3 times t minus 2. So I end up getting that it has a height of 100 at 3 seconds and at 2 seconds. So it looks like you start here at time 0, and when you get to 2 seconds, you hit 100 feet, and then between 2 seconds and 3 seconds, you're above 100 feet, and then you're back to being below 100 feet. So we can say that between t equals 2 and t equals 3, the ball is above 100 feet high. I know that was a little rushed.